Welcome. Today, we are looking at electrolysis at an advanced level. This is a key topic in your chemistry exams for SS2. Pay close attention. Let us begin. First, let me explain what electrolysis is. Electrolysis is the decomposition of an electrolyte by the passage of an electric current. An electrolyte is a substance that conducts electricity when dissolved in water or melted. The electrolyte contains ions that can move freely. When an electric current is passed through the electrolyte, the ions move to the electrodes. Positive ions move to the negative electrode, which is called the cathode. Negative ions move to the positive electrode, which is called the anode. At the electrodes, chemical reactions occur. Ions gain or lose electrons. This results in the formation of new substances. Electrolysis is used in many industrial processes. It is used to extract metals, purify metals, and electroplate objects. It is also used to produce chemicals like chlorine and sodium hydroxide. Understanding electrolysis is essential for understanding electrochemistry. Now, let me explain the key terms in electrolysis. The electrolyte is the substance that conducts electricity. It contains ions. The electrodes are the conductors that connect the electrolyte to the external circuit. The cathode is the negative electrode. Reduction occurs at the cathode. Positive ions gain electrons at the cathode. The anode is the positive electrode. Oxidation occurs at the anode. Negative ions lose electrons at the anode. The anion is a negative ion. It moves to the anode. The cation is a positive ion. It moves to the cathode. The electric current is the flow of electrons through the external circuit. The circuit is completed by the movement of ions in the electrolyte. Electrolysis requires a source of direct current. A battery or power supply provides the direct current. Electrolysis is the reverse of a voltaic cell. Now let me explain the electrolysis of molten sodium chloride. Sodium chloride is an ionic compound. When melted, it contains Na+ and Cl ions. The ions are free to move. The cathode is the negative electrode. Na+ ions move to the cathode. At the cathode, Na+ ion gain électron. They become sodium atoms. The reaction is Na++ E equals Na. Sodium metal is produced at the cathode. The anode is the positive electrode. Cl ions move to the anode. At the anode, Cl ions lose electrons. They become chlorine atoms. Two chlorine atoms combine to form a chlorine molecule. The reaction is 2Cl, 2E equals Cl2. Chlorine gas is produced at the anode. The overall reaction is 2NaCl equals 2Na+ Cl2. Sodium metal and chlorine gas are produced. This is the industrial method for producing sodium and chlorine. Electrolysis of molten sodium chloride is used in the down cell. Now let me explain the electrolysis of aqueous sodium chloride. When sodium chloride is dissolved in water, the solution contains Na+, Cl, H+, and OH ions. The water also undergoes electrolysis. At the cathode, water is reduced. H+ ions gain electrons. Hydrogen gas is produced. The reaction is 2H2O plus 2E equals H2 plus 2OH. At the anode, Cl ions lose electrons. Chlorine gas is produced. The reaction is 2Cl, 2E equals Cl2. The products are hydrogen gas, chlorine gas, and sodium hydroxide. This is the industrial method for producing chlorine and sodium hydroxide. It is called the chlor-alkali process. The products are used to make plastics, bleach, and many other chemicals. Now let me explain the electrolysis of water. Water can be electrolyzed by adding a small amount of acid or base to make it conductive. At the cathode, hydrogen gas is produced. H+ ions gain electrons. The reaction is 2H+ plus 2E equals H2. At the anode, oxygen gas is produced. OH ions lose electrons. The reaction is 4OH, 4E equals 2H2O plus O2. The overall reaction is 2H2O equals 2H2 plus O2. Electrolysis of water produces hydrogen and oxygen gases. Hydrogen is used as a fuel. Oxygen is used in many industrial processes. Electrolysis of water is a promising method for producing clean hydrogen fuel. Now let me explain the electrolysis of copper sulfate solution. Copper sulfate solution contains Q2 plus and SO42 ions. At the cathode, Q2 plus on gagne électron. Copper metal is deposited. The reaction is Cu2 plus 2E equals Cu. At the anode, water is oxidized. Oxygen gas is produced. The reaction is 2H2O 4E equals O2 plus 4H plus. The copper deposited at the cathode is pure. This is used in the purification of copper. Impure copper is used as the anode. Pure copper is used as the cathode. As the current passes, copper dissolves from the anode. It deposits on the cathode. Impurities fall to the bottom. This produces very pure copper. Electrolysis is also used for electroplating. Electroplating is coating one metal with another. For example, silver plating is done using silver cyanide solution. The object to be plated is the cathode. Silver is the anode. Silver ions deposit on the object. Electroplating is used to protect metals from corrosion and to improve appearance. Now let me explain Faraday's laws of electrolysis. Faraday's first law states that the mass of a substance deposited or liberated at an electrode is directly proportional to the quantity of electricity passed. The quantity of electricity is measured in coulombs. 1 coulomb is 1 ampere second. The mass deposited is also proportional to the equivalent weight of the substance. The equivalent weight is the molar mass divided by the number of electrons transferred. Faraday's second law states that when the same quantity of electricity is passed through different electrolytes, the masses of substances deposited are proportional to their equivalent weights. These laws allow calculations of the amount of product formed. The formula is mass equals current times time times equivalent weight, divided by 96500. 96500. 0 is Faraday's constant. It is the charge of 1 mole of electrons. For example, if a current of 2 amperes is passed through copper sulfate solution for 30 minutes, the mass of copper deposited can be calculated. First, calculate the charge. 2 amperes times 30 minutes times 60 seconds equals 3,600 coulombs. Then use the formula. Mass equals charge times equivalent weight divided by 96500. The equivalent weight of copper is 63.5 divided by 2, which is 31.75 grams per mole. The mass is 3,600 times 31.75 divided by 96500. This equals 1.18 grams. Faraday's laws are important for industrial electrolysis. Now, let me explain the factors affecting electrolysis. Several factors affect the products of electrolysis. The nature of the electrolyte is important. The ions present determine which reactions occur. The concentration of the electrolyte affects the products. In dilute solutions, water may be electrolyzed instead of the ions. In concentrated solutions, the ions may be electrolyzed. The nature of the electrodes is also important. Inert electrodes like platinum or graphite do not react. Active electrodes like copper or silver can dissolve. The voltage applied affects the rate of electrolysis. Higher voltage increases the rate. The current also affects the rate. Higher current increases the rate. The temperature affects the conductivity of the electrolyte. Higher temperature increases conductivity. These factors must be considered in industrial electrolysis. Now let me explain the applications of electrolysis. Electrolysis is used in many industries. It is used to extract metals from their ores. Aluminium is extracted from bauxite by electrolysis. Magnesium is extracted from magnesium chloride. Sodium is extracted from molten sodium chloride. Electrolysis is used to purify metals. Copper is purified by electrolysis. Gold and silver are purified by electrolysis. Electrolysis is used for electroplating. Silver plating, gold plating, and chrome plating are common. Electrolysis is used to produce chemicals. Chlorine, sodium hydroxide, and hydrogen are produced by electrolysis. Electrolysis is used in batteries and fuel cells. Electrolysis is used in the production of aluminium foil and cans. Electrolysis is essential for modern industry. Now, let me explain the difference between electrolysis and voltaic cells. A voltaic cell produces electricity from a chemical reaction. An electrolytic cell uses electricity to cause a chemical reaction. In a voltaic cell, the chemical reaction is spontaneous. In an electrolytic cell, the chemical reaction is non-spontaneous. In a voltaic cell, the anode is negative and the cathode is positive. In an electrolytic cell, the anode is positive and the cathode is negative. In a voltaic cell, oxidation occurs at the anode and reduction at the cathode. In an electrolytic cell, oxidation also occurs at the anode and reduction at the cathode. The difference is the direction of electron flow. In a voltaic cell, electrons flow from anode to cathode through the external circuit. In an electrolytic cell, electrons flow from the power supply to the cathode and from the anode back to the power supply. A common exam question asks you to explain the electrolysis of molten sodium chloride. Here is a sample answer. Molten sodium chloride contains Na+ and Cl ions. At the cathode, Na+ ions gain electrons to form sodium metal. At the anode, Cl ions lose electrons to form chlorine gas. The overall reaction is 2NaCl equals 2Na plus Cl2. Sodium metal is produced at the cathode. Chlorine gas is produced at the anode. This is the industrial method for producing sodium and chlorine. Another exam question asks you to apply Faraday's laws to calculate the mass of a product. Here is your answer. Faraday's first law states that the mass deposited is proportional to the charge passed. The charge is current times time. The mass is charge times equivalent weight divided by Faraday's constant. Faraday's constant is 96500 coulombs per mole. The equivalent weight is the molar mass divided by the number of electrons transferred. Use the formula to calculate the mass. Another exam question asks you to distinguish between electrolytic and voltaic cells. Here is your answer. A voltaic cell produces electricity from a chemical reaction. An electrolytic cell uses electricity to cause a chemical reaction. In a voltaic cell, the reaction is spontaneous. In an electrolytic cell, the reaction is non-spontaneous. In a voltaic cell, the anode is negative. In an electrolytic cell, the anode is positive. Both involve oxidation at the anode and reduction at the cathode. Let me give you a quick summary. Electrolysis is the decomposition of an electrolyte by an electric current. Electrolytes contain ions that move to the electrodes. At the cathode, reduction occurs. Positive ions gain electrons. At the anode, oxidation occurs. Negative ions lose electrons. Faraday's laws relate the mass deposited to the charge passed. Electrolysis is used in metal extraction, purification, and electroplating. Electrolytic cells use electricity to drive non-spontaneous reactions. Practice these concepts. When you have them down, move to topic 3.